Hello and welcome to your last section of Algebra 2. Today we're going to look at 13.5, which is the law of sines. Back in section 13.1, we learned how to solve right triangles. Now, in the real world, we don't always have right triangles. So in order to solve a triangle with no right angle, we need to know the measure of at least one side and any two other parts of a triangle. Now, in this section of 13.5, we're going to deal with two different cases. Okay, and the two cases are going to be the first case, which deals with two sides and an angle, which from geometry would be your angle side, or your angle side angle. Or the second case would be where we have two sides and an angle that is opposite of one of those sides, and that would be your side angle. For any other situation, if you guys remember from geometry, like the side, or the side angle side situation, those would be used, or we could solve those triangles using the law of cosines, which we're not going to get to this year. So for our purposes right now, we just have to look at angle side, or angle side angle, and the side angles. Now the law of sine actually says that if triangle ABC, and triangle ABC is located right here, has side lengths of A, B, and C as shown. Okay, and if you recall from geometry, the lowercase letters indicate the side lengths, and the lowercase letters are always opposite of the angle that they belong to. So side length B here is opposite of angle B, which is represented with a capital letter. Side length A is opposite of angle A, and side length C is opposite of angle C. So if we have these side lengths identified, then the law of sine says that I can take the sine of angle A divided by its side length and set that equal to the sine of angle B divided by the side length of B, which is also equal to taking the sine of angle C and dividing that by the side length of C. Now you don't need all three ratios. You only need two of the three to be able to solve for either a side length or an angle. Now the equivalent form of this up here would be to take the side length of A and divide that by the sine of A, or we could take the side length of B and divide it by the sine of angle B, which is the same thing as taking the side length of C and dividing it by the sine of C. Now again, you only need two out of the three ratios in order to solve for the unknown side or angle, depending upon what we've been given. So let's go ahead and look at an example. So for example 1, it says to solve triangle ABC with angle C as 107 degrees, angle B as 25 degrees, and side length B as 15. Now the first thing I'm going to do is I'm going to sketch the triangle so that I know what I'm looking at and dealing with. So when I fill in what's been given, I know that C is 107 degrees, angle B is 25 degrees, and side length B, which is opposite of angle B, is 15. Now we have two out of our three angles, so we can actually go in and solve for angle A by taking 180 and subtracting 107 and 25 degrees from that. And when we do that, we see that we have 48 degrees. So angle A is 48 degrees. Next, I see that we still have to find side length A, which is over here, and side length C. So let's go ahead and start out by finding side length A. And we can use that by using the ratio that A divided by the sine of 48 degrees is equal to, the only ratio I have both a side length and an angle for is B. So I'm going to take side length B, which is 15, and divide that by the sine of 25 degrees. Now, it doesn't matter which ratio you use, whether you put the sine in the top and the side lengths in the bottom, or the side lengths in the top and the sines on the bottom, you just have to be consistent. So because I put my side length of A in the numerator and my sign in the denominator, I must also do the same thing when I plug in the side length of b and the sine of b. So it doesn't matter which ratio you use, you just have to be consistent. So now to go ahead and finish simplifying this, I can cross multiply. So if I cross multiply these, I see that we have a times the sine of 25 degrees is equal to 15 times the sine of 48 degrees. And to get a by itself, I'm going to divide everything by the sine of 25 degrees. So we have a equals 15 times the sine of 48 degrees divided by the sine of 25 degrees. Now when you plug this in your calculator, you have to make sure that you are in degree mode. If you are not, you will not get the correct answer. So assuming you're in degree mode and you multiply and divide correctly, you should get side length A as 26.4. Now I'm going to go through and do the exact same thing for side length C. Except now I'm going to start with C in my numerator and the sine of angle C, which is 107 degrees. And I'm going to set that equal to 15 divided by the sine of 25 degrees. Now you could have used angle A and the side length of A, but personally I like to use the stuff that was given to me. So now to simplify this, I have C times the sine of 25 degrees is equal to 15 times the sine of 107 degrees. When I divide by the sine of 25 degrees, we get C is equal to 15 times the sine of 107 degrees divided by the sine of 25 degrees, and this then will give us a length of 33.9. And that concludes this example. Now sometimes we can get, when we go to calculate a triangle, we may not actually get a real triangle, or we'll get an error when we go to find an angle, okay? And that is because when we are given two angles in one side, or an angle-angle side or angle-side-angle case, we'll get exactly one triangle. However, if we're given a side-side angle triangle, okay, this is called an ambiguous case because we may get one triangle, two triangles, or no triangles at all when we calculate this out mathematically. So let's look at a couple different scenarios here. Okay, from this triangle, I see that I have an angle and a side and another side. So I have my side-side angle triangle. So I know that that will produce either one triangle, no triangles, or two triangles. So the first thing I'm going to do is I'm going to set up my problem. And I see that angle A is 115 degrees. Side length A is 20, and side length B is 11. So I'm going to use my law of sines to come up with angle B, because that's the only angle I can find at this point since I don't have an angle C and I don't have a side length of C. So for angle B, I'm going to use the sine of B divided by 11. And because I use this sine in the numerator, I'm also going to use the sine of angle A in the numerator as well, or the sine of 115 degrees. And I'm going to divide that by the length of A, which is 20. So when we cross multiply, we get 20 times the sine of B is equal to 11 times the sine of 115 degrees. To get the sine of B piece by itself, we have to divide everything by 20. So the sine of B is equal to 11 times the sine of 115 degrees divided by 20. And if you put this in your calculator, you'll see that this is approximately 0.4985. And if you recall from geometry, in order to find that actual angle now, we have to use the inverse sign. An inverse sign is on your calculator. You have to hit the second button, which is the blue button at the top left corner, and then you're going to hit sign. So above the sign button, you'll see in blue letters it says SIN, and then that's being raised to the negative first power. That is your inverse sign button. And when we do the inverse sign of 0.4985, you should get something close to 29.9 degrees. So that tells me then that angle B is 29.9 degrees. So now, because my triangle as a whole has 180 degrees to it, I can subtract out the 115 degrees from angle A and the 29.9 degrees from angle B, and that's going to tell me then that angle C is equal to 35.1 degrees. So 35.1 degrees is angle C. Now the only thing we have left to find is side length C. So we're going to use, again, I always use the ratio of sides and angles that were given to me. So I'm going to use the sine of 115 degrees divided by 20. And let's scoot this up here. So we have the sine of 115 degrees divided by 20 is equal to the sine of angle C, which we just found to be 35.1 degrees, divided by side length C, which we do not know. So if we continue to solve this, then we have C times the sine of 115 degrees is equal to 20 times the sine of 35.1 degrees. I need to get C by itself, so I need to divide by the sine of 115, or C equals 20 times the sine of 35.1 divided by the sine of 115. And again, you must be in degree mode. So if you put your calculator in degree mode and calculate this out, you should get a side length of 12.7 for side length C. And this will then conclude our second example. For example 3, we want to solve triangle ABC with angle A at 51 degrees, side length A at 3.5, and side length B equal to 5. Now again, I'm just going to set up my ratios. I'm given angle A and side length A, so I'm going to set this up as 3.5 divided by the sine of 51 degrees is equal to, I'm only given side length B, so that means I have to find angle B then. So the sine of B, when I cross multiply, I have 3.5 times the sine of B is equal to 5 times the sine of 51 degrees. And to solve for B, we have sine of B is equal to, and I'm going to divide both sides by the 3.5. So we have 5 times the sine of 51 degrees divided by 3.5. And when we simplify that, we get 1.110. And if you take the inverse sine, so that we can solve for angle B then, in my calculator, when I do that, I get an error message. So because we get an error message, this tells me that this triangle cannot exist. And if you actually go ahead and try to sketch this triangle to the correct dimensions with an angle of 51 degrees and a side length of 3.5 and a side length of 5, you will see that your triangle will not actually connect. You'll end up with something that looks like this, and it falls short. So you have this gap right here, and because of that gap, the triangle is not able to be created. So then I know that this triangle does not exist. Now for example 4, we have to solve triangle ABC with angle A at 40 degrees, side length A at 13, and side length B at 16. So again, I have two sides and an angle. I'm going to set my triangle up. I'm given side A and angle A, so I can say 13 divided by the sine of 40 degrees is equal to, and I'm going to use side length B, which is 16, divided by the sine of B. When we cross multiply, we have 13 times the sine of B is equal to 16 times the sine of 40. And when we solve for the sine of B, so we'll say sine B is equal to 16 times the sine of 40 degrees divided by 13. This here will give us 0.7911. And when I go ahead and solve for angle B, by taking the inverse, I get 52.3 degrees. So here is angle B. Now, because I know what angle B is, I can then go in and find angle C. So I have 180 degrees minus my angle B, which was 52.3 degrees, minus the 40 degrees that was given for A. This is going to give us 87.7 degrees for angle C. So now I'm going to go and find side length C, and I'm going to use the 13 divided by the sine of 40 is equal to side length C divided by the sine of 87.7 degrees. And when we do this, this is going to give us 13 times the sine of 87.7 equals C times the sine of 40. So C then is equal to 13 times the sine of 87.7 degrees divided by the sine of 40. And this is going to give me 20.2 for a side length of C. Now we have a second scenario where we could possibly have a second triangle. And in order to determine if we have a second triangle, we need to take our 180 degrees, which is our interior measurement, or the sum of all the interior angles added together, okay, and subtract what we found for angle B in triangle 1. So I'm going to subtract 52.3 degrees, and this is going to give me 127.7 degrees. So now, if I'm able to take 180 degrees and subtract that 127.7 degrees and the initial 40 degrees that was given to me for my angle A, if I get an angle that is a positive number, then this tells me that a second triangle exists. If I get a negative number, it tells me that a second triangle doesn't exist and only one triangle is possible then. So in this case, if I do 180 minus 127.7 minus 40, this will give me my new angle C, and this is 12.3 degrees. So now the 127.7 degrees is my angle B, and the 12.3 degrees is my new angle C. So we'll say B is 127.7 degrees, and angle C is equal to 12.3 degrees. Now that I know these two angle measures, I have to go and recalculate the side length C for the second triangle. So to do that, I'm now going to use my angle A and side length A. So I have 13 divided by the sine of 40 degrees is equal to my new side length C divided by the sine of my new angle C, which is 12.3 degrees. So when I go ahead and solve for side length C of my second triangle, we have 13 times the sine of 12.3 degrees is equal to C times the sine of 40 degrees, or side length C then is equal to 13 times the sine of 12.3 degrees divided by the sine of 40 degrees. And when we calculate all of this out, we see that side length C is actually equal to 4.3 units. Now the last thing we're going to look at out of section 13.5 deals with the area of a triangle. We have three ways that we can calculate the area. We can take 1/2 times B times side length C times the sine of angle A. I can take 1/2 times side length A times side length C times the sine of B, or I can take 1/2 times the side length A times the side length of B times the sine of angle C. And it will all depend on which side lengths and angles you are given. Now, you don't have to memorize all three equations. All you have to know is if you're going to use two adjacent sides. So let's just look at this angle here, at angle A. If I want to find the area of this triangle and I know side length B, which is here, side length C, and angle A, I'm going to multiply 1/2 by the two side lengths that I know, B and C, and then I have to include A in there somewhere, so then I must multiply by the sine of angle A as well. Okay, and if you have trouble remembering that, come see me and we'll go through and practice this. So our last example deals with finding the area of triangle ABC with the given side lengths and the included angle. So from the triangle that I've sketched here with the given sides and angle, I know that if I want to find the area is going to equal 1/2 times the two side lengths, which I do know. So I have 14 times 10 times the sine of the angle that I know as well, which in this case is the sine of 46 degrees. Now when you simplify all of this, you should get 50.4, and because this is area, we really have square units. So if you have any questions, please come and see me. And for your fun fact, and this is probably your favorite fun fact of the year, this will be the last section that you will cover in your Algebra 2 career. I've enjoyed having you in class, and I wish you guys all the best of luck. And I hope to see you in pre-calc next year.